Today, we're digging into the periodic table to find an element so aggressive, it's hard to believe it even exists. So let me just ask you this. What if I told you there's an element out there that can eat right through solid glass? And get this, it can literally dissolve your bones from the inside. I mean, what on earth could be that destructive?
Well, the answer is probably not what you're thinking. To figure this out, we first have to ask ourselves, what does dangerous even mean? Are we talking about radioactivity, or is it something else entirely?
Okay, so let's look at our first suspect, francium. You find it way down at the bottom of the alkali metals on the periodic table, and it is known for being incredibly unstable. It's actually so rare you can barely find it in nature.
Now, the case for francium looks pretty strong, right? It's super radioactive, which means its nucleus is literally falling apart. And because it's an alkali metal, you'd expect it to be just violently reactive. I mean, its most stable version has a half-life of only a few minutes. It's definitely a bad actor. But is it our glass eater?
So this is the absolute key to the whole puzzle. Being radioactive and being chemically reactive are two totally different things. Radioactivity? That's all happening in the nucleus. The atom's core is unstable. Reactivity, on the other hand, is all about the outer electrons and how desperately they want to bond with other atoms. And that little difference, it changes everything.
While francium's radioactivity is definitely dangerous, the kind of terror we're looking for, it comes from pure, unfiltered chemical aggression. We're on the hunt for the ultimate chemical bully of the periodic table.
And here it is, our real culprit, fluorine. I mean, this quote really says it all. It is, hands down, the most chemically reactive nonmetal there is. It's this pale yellow gas that wants to start a fight with pretty much everything it meets. And what's just wild is how indiscriminate it is. Fluorine is so desperate to react that it will go after almost any other element. It'll even attack some of the so-called noble gases. You know, the ones we used to think were completely inert, like xenon and krypton. Nothing is safe. Just to give you an idea of its ferocity, most chemical reactions need a little push, right? A spark, some heat, a bit of light. Not fluorine. It will react with hydrogen explosively, even if it's cold and in total darkness. It's not waiting for an invitation to the party, it's kicking down the door. Okay, so we've established that fluorine is an absolute chemical monster. But let's circle back to our original question. Can it really destroy glass in your bones? You bet it can. And this is where the story gets genuinely chilling. See, elemental fluorine is a gas, but the real danger is what happens when it reacts. It forms these compounds called fluorides, and as you can see here, fluoride toxicity is no joke. It leads directly to the demineralization of your bones, making them brittle. Let's get specific and talk about a compound called hydrogen fluoride. First, it absolutely attacks glass. It just dissolves the silica that holds the glass together. Second, it is unbelievably dangerous to people. It causes these awful burns that just don't heal well. And third, and this is the terrifying part, it soaks right through your skin, hunts down the calcium in your body, and starts destroying your bones from the inside out. So there you have it. We found an element whose compounds can dissolve glass and bone. Case closed, right? Well, not so fast. The story of fluorine has this one really bizarre twist. And here's the great paradox. If this stuff is so incredibly dangerous, then why in the world do we intentionally put its compounds in our drinking water and brush our teeth with it every single day? It sounds completely bonkers. But it's not just in toothpaste. Fluorine compounds are literally everywhere. They're the secret behind non-stick pans like Teflon. They're used to help make steel. And for decades, they were in all our refrigerators and aerosol cans. We somehow managed to take this absolute chemical tiger and put it to work for us. So how does it help our teeth without, destroying them? Well, it's actually a beautiful little piece of chemistry. Our tooth enamel is made of a stuff called hydroxyapatite. When fluoride ions show up, they swap in and create a new compound called fluoroapatite. And here's the kicker. This new stuff is way, way tougher against the acid from bacteria that causes cavities. This incredible duality is what makes fluorine so fascinating. It really is all about the dose and the form it's in. The pure element is a nightmare, but in the right compounds and in the right amounts, it's actually our protector. So the main thing to take away from all this is that fluorine is the perfect example of chemistry's two faces. On one hand, it's the most reactive, aggressive element we know, a true extremist. But through science, we figured out how to harness that extreme personality and turn it into a tool that keeps us healthy and makes modern life possible.
And that kind of leaves us with one final thought, doesn't it? Fluorine was this hidden danger we managed to tame into an everyday ally. It really makes you wonder, what other powerful forces of nature are just out there, waiting for us to understand them?